In this section, we'll show you how to create a relatively simple script that will back up a current directory or a specified directory, zip the contents, store it as a tarballed gzipped archive, and then use the SSH facility to SCP, Secure Copy Protocol, the file over to a remote host. It's a neat way to back up directories and files locally to your system and to also securely preserve a copy on a remote system. Let's open a shell and define the script. You'll find that you'll use a backup script for many of your tasks, such as backing up web directories and other types of directories and files that contain scripts and valuable information on your system. We'll create a new file as backup scripts.shell with standard headers. And always good to include the date. Optionally, the modified date would help as well. Purpose: used to back up files and or directories locally and store remotely. Keep this on one line so that the shell doesn't interpret it. And we have our end, and we'll begin with the body. So first and foremost, what do we want to back up? We should define variables that correspond to the points of interest. Let's set a variable for backup directory called backup directory. Backup dir is equivalent to root temp2. We can use tilde expansion here so that the script becomes more portable, for example, for another user on the system. So let's use tilde expansion and specify the backup directory as a default backup directory. That's fine. We'll also show you how to create the directory from the script on the fly if it doesn't exist. So we have a backup directory. What else is of interest for us? We want to back up a specific directory. This is the backup location where to store files. Let's define a variable for the script directory, the directory we actually want to back up. So the backup directory is where we'll store the backups. Script dir is equivalent to, and it's also based on tilde. It's stored in a directory called temp2. So we want to back up the script directory and place those files in the backup directory. So now we have a few variables we can work with. Now the command that we'll be using to back up to create a tarballed gzipped file is called tar, and tar can roll the files into a tarball archive, or tar archive, or a tape archive, as well as compress it. We're using gzip or optionally bzip compression. So we want to run the tar command on the contents of the backup directory. We also want to give the file that we back up a name. So let's define a variable for the backup file. This one will be called backup file, and it'll be called whatever we want it to be. Let's say, for example, scripts.backup, and we should specify a date. It's a good, or is good practice to include the date in files that you create, especially files such as backup files, so that you know when it was performed. Aside from, of course, the file's built-in modified date timestamp, it's good to append it within, or embed the date and timestamp within, or just at least the date within the file name. So here we need command substitution. The backup file will have a prefix of scripts.backup. And we'll use command substitution to gain or ascertain the output of the date command. And we'll use the %f variable to get the current date. And this should do it for the file that we want to back up. So we have a directory, we have the script directory, which is the directory we want to back up, and we have a backup file. Excellent. Now let's start typing some of our commands. We're not yet finished defining variables. We'll just at least get step 1 to work. So the command is tar, and the switches are as follows: czvf. C will create, Z uses gzip compression, v verbose, etc. So we want to czvf, and you can always research the arguments that tar accepts to see what all the options provide. And we need to specify here the backup file name. Now we don't need to type in a name, we simply need to use the variable backup file. So the first thing we specify that tar expects is a backup file, and then it also expects a directory to back up. So we'll give it the variable backup directory, or in this case script directory. Now this will be stored in the backup file, but we don't want the backup file to be stored within the script directory. So what we'll do is we'll prefix backup file with backup directory. This would work if we didn't do anything, but the file would be outputted to the script directory, and that's not what we want. So that's why we've defined a variable called backup directory, which we could have made a part of the backup file variable, but it's good to separate them just in case things change down the line. You can change one component without impacting the other. So we're going to create a file in the backup directory, which is located in root backup. It will have a name of scripts.backup.date, expanded using command substitution, and we'll back up the script directory. We're not yet ready to copy this file over to the remote host, and we also haven't put in additional logic. Let's just run this and see what breaks or what works. We'll change mod u+x backup scripts. If you want the script to be usable by other users on the system, then make it executable by all users on the system, or at least the user and or groups that you're interested in. Now let's run backup scripts.shell. Recall, it's going to back up everything in this directory, including subdirectories. By default, tar will search through subdirectories. In other words, it will function recursively, and it will store the output in root backup. Now currently root backup doesn't exist, so let's make that directory. We'll use tilde expansion and create the backup directory, and let's run the script. Here are all the files outputted to standard out. Now let's LSL the contents of root backup to see what's there. There's our newly created file, scripts.backup.2004-8-29. It's quite simple, but of course we can make this much fancier. Now as you can see, the file is smaller. Let's DUH our current directory. It's 1.6 megs, but the backup file is a mere 488K. So it's roughly a third, a little bit more, or a little bit less than the original file. A little bit less than the third. So we've gotten great compression. After all, these files are all ASCII text files, so there are redundant characters that can be compressed. So we have a simple backup script going on that we could put into the cron scheduler. But what if we wanted to do more? What if we want to set a threshold? I'm always interested in thresholds such as backup files for 7 days, and after the 7th day, do nothing else. But let's show you how that would work. Let's peek out a backup shell script, and we could set up a threshold in here, which could be driven by positional parameters, by the way. Threshold is a nice variable, or a nice variable name. Threshold is equivalent to some value. Let's say that value is 7. After 7 instances, we don't want the script to create additional files. We should also set a variable called count. Now what count will do for us is it'll ascertain the number of files that exist within the backup directory. So count is equivalent to, and of course we need command substitution for this, we'll use the ls command to list the contents of the backup, or the backup directory where the actual backup files are stored. So we can pass in the parameter backup directory. But we're not done. We need to actually output this to the word count utility to get the number of lines that are returned. So you see what's going on here. Let's ls-a just to get us back the files for no confusion. So count will store the value of the number of files that are in this particular directory. We could be more specific. We could avoid the A option and get more specific by specifying backup dir or backup dir slash scripts dot star, for example, since we know that all backup files will contain a prefix of scripts dot. That'll help as well, and then pass those number of files found into the word count utility, which will count the lines, and then we'll have something to compare. So we'll compare count against threshold. Now we're ready for our conditional. If, again, and you've seen us do this time and time again, if count is actually less than or equal to, in this case, less than or equal to the value of the threshold, then it's okay to do it. So if it's 1, 2, 3, 4, 5, 6, 7, it's okay. After 7, it's not okay. So if it's less than or equal to threshold, then perform the body of this particular conditional. Then we'll tar, and then we'll close the logic. So if and up to the point of the threshold, perform the tarred function. Now we won't be able to push this up to 7 because we've prefixed or we've suffixed the backup file with a date which contains a date and not a timestamp. So it'll only have one file. So we can run it many times. It'll simply overwrite the same file name, at least for today. But if you were to let this script run for 7 days, you'll see it'll create 7 files, and on the 8th day, it won't create that 8th file. Excellent. So we have that logic in. Let's try to run it to see if anything has broken. And as you can see, it still runs. If we lsl tilde backup, you'll see that the file was just created, 1409. It overwrites the file, by the way. But on a new day, let's say tomorrow, August 30th, if the script were executed tomorrow, or is executed tomorrow, a new file scripts.backup.2004-8-30 would be created. And it would keep rolling until it hits the 7th day, and on the 8th day it would fail. So we have the logic in there for that. How about actually copying this file over to the Debian box, or over to a remote host? We have a remote host here which happens to be a Debian system, which is set up to accept these files. So what if we wanted to copy it over? Well, we could just put a step in using SCP, the Secure Copy Protocol software, which is a part of the SSH tools. SCP, the backup file, and we can specify backup dir and backup file so that this is more portable. So SCP backup dir /backup file, and send it to some host called backup host. Now we've yet to define backup host, so let's do so. And we keep messing up our formatting here because whenever we go to uppercase and try to use the keys, it messes up. So let's define a backup host. Backup host will be our Debian box located at 192.168.1.20. So we'll SCP over to the backup host, and we'll terminate it with a colon. This will place the file in the home directory of the currently logged in user on the remote system. Let's show you how this works. Let's run the script, and it's going to prompt us for authentication. Now we need to authenticate. So the file has been created, but we need to authenticate to the remote system. There's a simple password set up over there of ABC123. The file has now been copied. Now let's open a new shell, and before we do, let's just echo the variable to ensure that it's an error level of 0. Let's open a new shell, SSH over to 192.168.1.20 to show you the new file as it's created. We can ls letter, and here it is, scripts.backup829.tgz. In this case, it's the one without tgz, so we need to modify our script so that the file actually has that extension. Not that it has to, but it's common practice to end the file with tgc so that the reader recognizes that the file has been tarred and gzipped. And if you do it with bzip compression, make the extension bz2. Excellent. So that section of the code is working. We could also do some more in here, such as if we could put some error handlers in within the nested. So this is a nested if. If the file in this case, or if the error level in this case, if error level is not equal to 0, and we'll end this here, then echo problems creating backup file. And we could do the same thing after the SCP step. If error level is not equal to 0, most times it will be equal to 0, but if there are connectivity problems in this step, it'll fail. Then echo problems copying backup file, and we could echo the backup file name, but we don't need to. Backup file to backup host. Let's keep this on one line. So at least we have some error checking at each step of the way. Now let's try to run this again and see what the difference is. We're now prompted. We didn't get an error after the first step, and we won't get an error after this step because both error levels are okay. If we were to change the backup host to some other host, we'd then get an error level, such as the following. Let's change the backup host to a host that does not exist. And let's try to run the process again. Now it's actually at this step trying to connect to that host, and here we get the error. Problems copying backup file to backup host. At least we know if we were logging this that there was a problem. But we should reset it to the proper host so that we don't run into a problem. And let's try that again. And it'll prompt us for authentication. Now for this to work truly as an automated script, we should copy our public key over to the remote system's authorized keys file, and then we'd no longer be prompted for authentication. That's quite simple to set up and test. Also, as we've shown you before, you can suppress the output of some of the activities here by sending the output, in this case, to dev null, so it's not echoed on the screen. So when we rerun the script, we don't see everything here, and the file still gets copied over. The output's pretty much suppressed. So that's how you set up a backup script to perform this sort of function for you. Of course, like with anything we've shown you, you can change all these variables to positional parameters to do other things, but at least we're checking a count, etc. We could also, as I mentioned before, check to see whether or not the directory exists. And if the backup, or any of the directories, but in particular the backup directory, if it doesn't exist, we could then create the directory. That certainly is a possibility. Now here's a simple script. The most important part of this script is the fact that it tars the files up using tarball and gzip compression, and it saves a copy locally in the backup directory. Optionally, because it's always good to back up a backup, it copies, or the next step is it copies the newly created file over to the backup host. Additionally, we have a threshold going on here. We only want files for a threshold of 7 days. In other words, by 7 days we should clean up, just in case it grows too big, overwhelms the storage of one or the other host. So locally, the file exists within this directory, in the home directory of root user. The first file is there because we didn't have the TGZ extension, but the real one is this one, TGZ extension. And now that we have this going, it'll run for 7 days, and on the 8th day it won't create any files, which of course we could send an email. But the bottom line is we've used tar, we can use SCP, and as I mentioned before, you could copy your public key over to the remote host so that you wouldn't be prompted. So that's how you create a backup script, a simple script that is. You can take that script as an example to create more sophisticated examples to suit your environment. What we'll do now is expand the capabilities of our backup script. So as it stands, we've had to manually create a backup folder or backup directory in the home directory of the currently logged in user, root, and the script expects that particular directory to be there. We'll have the script gain some intelligence by being able to check for the presence of that directory. If not there, it'll create the directory. We'll also organize the script a little bit more. We'll also show you how to set up the public key so that the secure copy process works smoothly. Let's go to temp2, and we have the backup script in here. Let's ensure that in our home directory, the backup directory does not exist. And let's modify the backup scripts.shell. So what else can we do with this script? We're checking for threshold to ensure that we don't create too many files so that we have a rotation going on. Essentially, the threshold enables us to maintain a 7-day rotation. However, what about the backup directory? Let's put in some logic for the backup directory. Now, as I've mentioned before, the conditionals that bash provide are able to do comparisons, string comparisons, integer comparisons, and are also able to check on files on the file system. Let's put in some logic to check whether or not the directory exists, and this will be a not equal to. So we'll put in an if not in the -e option, if not file exists, and we'll use the variable that's previously defined for backup directory, So if not exists backup directory, then we'll do the following logic. Then echo creating backup directory because it does not exist. And we'll put that here, doesn't exist. Now notice the single quote. We'll need to escape the single quote. Let's escape it with the escape character so that it prints properly. But we've yet to create the directory. So the very next line will make directory root backup. So this directory needs to be created. Now this will help us, this bit of logic will help us in the event that the directory gets inadvertently deleted by perhaps the administrator or was never created in the first place. So it's all self-contained within the script. The script has enough knowledge to take care of the directory creation for us. So logic is simple. If not exists backup directory is defined up top, root backup. If not exists, then echo creating backup directory because it doesn't exist. Actually make the directory and then proceed with the script. We could even add an error level checker, another nested if, to ensure that the directory was created properly so that we don't run into problems with the rest of the script or the remainder of the script. Typically you don't have to, but it certainly is an option. Simply put a condition next. If the exit status has a problem, then abort processing of the script. Now what we'll do is here we'll purposely put in an exit status of 0 to have the script exit so that we can examine whether or not the directory was created. And then we'll comment it out and then proceed to processing. Let's Control X to save, and we'll verify that the directory does not exist in the root directory currently. It doesn't. I'm tabbing it out. Directory does not exist. If we echo the exit status, it comes back with 1 because it's not there. Now let's attempt to run the backup scripts.shell script, and it should search for the existence of that directory for us and echo creating backup directory because it does not exist. Ignore the first error that you see up here. This error is because the files don't exist within root backup scripts. In our first test, what we're testing when we assign the value to count is for the number of files that currently exist within backup scripts. We could also put a condition there. Let me show you that. In this section right here, we're actually assigning to count the number of rows that are returned when we do a glob on scripts.star. If it doesn't exist, it comes back with an error. So we could have a condition here first before setting it. For example, we could say, if not exists the backup directory, then count is equivalent to 0. We could even set count below in this section here. So, for example, let's move the count variable down to this section, and within the if backup directory, we can do the processing such as the following. We'll put else count is equivalent to whatever is there. Let's examine that. Now there may be a case where there are no scripts file but the backup directory exists, so that's something else to think about as well, because you may have a clean empty backup directory. But we'll set initially count to 0, because if the backup directory does not exist, then there's no way the files can be there. So count initially is 0 if we're just creating the backup directory, and this will at least allow us to proceed with the rest of the processing. However, if the backup directory does exist, we're assuming that backup files are there, and we will assign count to the value. We could nest, once again, another if right in here which says if no files exist with the prefix of scripts.star, then set count to 0. Else set it to what it really does exist, or the values that it exists to. But that's a bit much conditional. So currently, what will happen is as follows. We will exit after setting count to 0. Let's look at that again. Now if we LSL again in our home directory backup, you'll see that it exists. Let's remove it and rerun this particular script. We'll clear screen, we'll LSL, you'll see it doesn't exist. Now let's rerun the script. It created the directory for us, and if we LSL backup, it's there. But notice we didn't get a count error, which is excellent. So the backup directory now exists. Let's remove it one more time and run the entire script. Now let's modify the script, and we'll comment the exit 0 section. The exit 0 aborts processing at this point, so we want to, or any exit command for that matter, aborts processing and returns the value assigned to it. So we've told the script to exit 0 because we're in total control, but we don't want it to exit. We want it to continue processing. Excellent. Now let's run the script. The directory does not exist, and as you can see, it's running through the process. We get an error because we've suppressed the tar by sending it to dev null, but no sweat. Let's specify the password for the copy to take place, and now the copy exists on the remote system. If we LSL our local host, you'll see that the file has been created, scripts.backup exists, and it's on the system. Now if we rerun the script, it'll just simply rerun again, prompt us for logging into the remote system, and all is well. Excellent. We can LSL. You'll see there's only one file because it's premised on a prefix of scripts.backup.date, and we're not using anything else that makes it unique, so it simply overwrites the file. Now what else can we do to clean up the process here? Well, let's show you the public key, private key section that SSH relies upon. Let's navigate to our home directory, to a directory called SSH. It's a hidden directory. This directory contains quite a few files. It contains an authorize_keys file, which contains the public keys of remote hosts, remote users that we trust. So we have remote root equivalents on the Debian system and other systems that are able to log into our system based on their private key matching our copy of the public key. We also have a public key. It's stored in this id_rsa.pub file. We can cat its contents, and you'll see it contains a public key. We need to copy this string to the remote system's authorized key files. Now there's a utility SSH provides for that will automatically do that for you, and that's the SSH add. But what we'll do is we'll do it manually. We'll copy this RSA key, and we'll open another window. We'll just copy this into memory. It's quite easy. Control-Shift-T SSH over to 192.168.1.20. We'll authenticate, and we'll navigate into the remote system's SSH directory. Now, the remote system does not have an authorize_keys file, so we'll create one, but it's a Debian system, so it uses nano. We'll create an authorize_keys file, no extensions, and we'll paste using Control-Shift-V our key, and it's all on one line. Having said this, or having done this, we will now be able to log in from the remote host automatically. Let's show you that. We'll exit the Debian system, clear screen, we're back on our local host. Let's try to SSH into it, and if you notice, it doesn't prompt us. We've logged in based on the file authorize_keys, which has a copy of our public key. Excellent. And when we SSH over, we use our private key to encrypt the session, and only one public key is able to decrypt it. What does that all mean for our script? It means our script is going to run much smoother. Let's navigate to temp2. Let's remove the backup directory and start all over. Clear screen, and we'll run the script again. And that's the backup script. Now look at the difference. Excellent. It copies a file without prompting us. So that's another way to clean up the entire process. It created the backup directory for us, and it also SCP'd, or a secure copy protocol, the file over to the remote host. If we LSL the backup directory, you'll see it contains a file, and if we SSH over to the remote host, which we don't have a session to, we can ls letter. You'll see that the file is here, scripts.backup 2004, etc. The old one here is before we had the TGZ extension. In fact, we can remove that file, scripts.backup 829. Now if we lsltr, there it is. Excellent. So we have that part of the process running smoothly. What else can we do? We can clean up the presentation of this script. We can use functions, as we've shown you before. So we have a function here which checks the presence of the backup directory. Let's define it. We'll call this function check backup dir. We'll open brace, and at the bottom or at the end of it we'll close brace for one function, and we'll check or we'll define another function here. This section of the script actually performs the backup. So we'll call it backup. Open brace. And then at the end of it all, we'll close brace. So now we have two functions defined, and we'll list them appropriately. Check backup dir and backup. Those are the two functions. We have backup and we also have check backup dir, two functions that'll run. So now the script is run in a much neater fashion, and we can run it this way. Now let's just ensure that things still work. Remove RF, root directory, backup, get rid of it. On the remote host, we can also remove the scripts.backup file to ensure that it's not there. Nothing's here as well. Doesn't exist. Excellent. Now let's run the file again. And it's running. And it's gone through the entire process. So we've created functions, we have set up a public key, and we've streamlined this process much nicer. If we LSL backup, you'll see it here. And if we look at the remote host, it's also here. Scripts.backup just got deposited. So essentially, the way you get better at scripting is to just keep revisiting the scripts that you've created. And you'll see different ways you can improve the script. Always, whenever possible, use positional parameters because it allows you to drive the script from an outside source, such as the command line or from a file. It helps out pretty well. You can set some of the values manually inside of the script, but it's always great to drive the script from an external force. But this is a simple way to back up a directory. I want to show you one other thing before we close this subject. How do you actually back up multiple directories? What if you want to back up several directories, for example? So we're interested right now in script dir being temp2. Well, we could back up two directories. Let's enclose it within quotes. We want temp2, and we also want, let's say, /etc. Now remember, when you're defining your scripts, your parameters are defined by the capabilities of the binaries that you call, or the programs that you call from your script. So really, we're only constrained by the limits of tar in this case. Tar can certainly accept multiple directories on the command line for backup purposes. So tar, when run now, will essentially back up the script directory, but in this case, it knows that the script directory equates to two different directories. Let's look at it in action. This is the beauty of having scripts and variables. Let's remove RF, backup, just to get rid of any traces. Let's do the same on the Debian host. We'll remove RF scripts. We'll clean it up. And let's rerun the script. Now tar is running again, and it's going to actually go through the temp2 directory as well as etc. etc is much bigger and contains many more subdirectories, so it'll take a while longer to get everything. Well, once it's complete, the file will be ready to copy over to the remote host. Excellent. So now it's much bigger. It's actually 2 megs. And if we wanted, we could echo the contents to the screen so we see what exactly was backed up. We could even use tar to examine it. Let's modify the script, and we'll take off the redirect to dev null. Let's get rid of this, and you'll see flying on the screen what's exactly, or what's happening as it happens. There you see etc being backed up and stored within. Now remember, as I mentioned before, tar backs up recursively, so those are all the subdirectories you see flying across the screen being included in our new tarball gzipped archive. It takes a while because there are many directories and files. The system has been up for years, but nonetheless it's done them all, including the temp2 directory. So it certainly has the capability of doing both, and it's copied it without prompting us. No problem. So this works pretty well. Not an issue at all. And there are many different things you can do with this file. Anything that comes to mind, just apply it. Simply study the script and see where you can perfect the process where possible. We have functions, we have variables. tar is working pretty well for this system. Another option I wanted to mention was the fact that you could use tar to back up with bzip2 compression, which achieves better compression. The parameters that you pass in, instead of czvf, will be cjvf. That's the only difference. And then you should rename the file to bz2 so that people recognize it. You can store the parameters that tar accepts in a variable so that you can change it somewhere else in the script. That's also certainly an option. But then, like I said, just change the file name to like BZ2 so that it's reflected, so that visually people recognize, or a subsequent observer or reader of the system understands what's happening on the system. Now let's show you this in action. When we run it, it'll run through all the directories, and the output will be stored in a bzip compliant format. Now gzip does not recognize the bzip format, so don't expect them to be cross-utility compatible. Nonetheless, bzip tends to get better compression, so you may want to use bzip. However, at a trade-off of typically slower speed. Just two different compression algorithms, but through your script you can determine the algorithm that's in use, and they could also be passed as positional parameters, for example, so that you could run the script from the command line and specify the compression algorithm that you're interested in using. Now let's LSL the root backup directory. As you can see, there are two files here. One's a BZ2 file and the other one's a TGZ, and you can compare them. If we alter the output of LSL, use LSH, as you can see, bzip2, the newly created file, created at 1653, is superior in size in that it's smaller. It's 1.7 megs, whereas the TGZ file is 2.1 megs. So that's a significant difference for backing up the same content. And now the content also resides on the remote host. We have scripts.backupTGZ, scripts.backupBZ2, and they're both the same size. We can LSL, show it in human readable, and you can see the difference, 1.7 versus 2.1. So those are a few other things you can do with your backup. But the important things, as I've mentioned, you can back up multiple directories using this script. You can drive all the variables using positional parameters, which you know how to use. And you can organize your code into nice units, functions, and you can also suppress the need for having to specify a password on the command line by copying the public key over to the remote host's authorized key files. And those are a few things you can do with backup. Certainly you can do more.